The inverse trig functions. Our objective for this video, find the exact value, if possible, of an inverse trigonometric function. So what do we know coming in that's going to be useful? Well, we know our sine, cosine, and tangent definitions when it comes to right triangles. We know our unit circle trig values. And we know what an inverse function is. An inverse function is a function that undoes a given function. Okay, for example, the square function, so squaring something, and the square root function are inverses. What that means is they each undo the other, okay, or each undoes the other. So if I say, okay, x squared equals 9, well, the square root function is the inverse, and I can solve for x by using the inverse function, which is the square root function, to get the values of positive or negative 3. The square root of 9 is positive or negative 3. So I had a squared function, I wanted to undo it, get rid of it. So the square root function undoes that. Let's go the other direction. The square root of 4 is, I made a mistake there. The square root of x is equal to 4. Okay, how do I undo this square root? Well, I will square both sides to undo that. And I come up with x is equal to 16. I do want to point out one thing here, okay? Recognize that the square root function is a bit restricted, okay? We're going to talk about its range, what comes out. Okay, this is a positive square root, and its range, what's going to come out of that, is always going to be positive or 0, so greater than or equal to 0. So the square root function has a range of greater than or equal to 0. This is going to come into play with our sine, cosine, and tangent inverses. All right, so move some things on my way here. Let's go to there, I think. In a right triangle, the trig functions, which are sine, cosine, tangent, etc., allow us to find the particular ratio for a given angle. So go back up to here, okay? Take the trig function sine. The sine of an angle is the ratio of the opposite over the hypotenuse. The cosine of an angle, is a ratio of adjacent over hypotenuse and then tangent. So the trig functions allow us to find the ratios. The inverse trig functions, okay, for example, inverse sine, sometimes called arc sine, inverse cosine, inverse tangent, etc., will do the opposite. It will allow us to find the angle for a given ratio. So the sine function, we can find the ratio for a given angle. The inverse sine function will find the angle for a given ratio. Okay, so if we take a right triangle, and we have an angle, okay, if I take the sine of the angle, I find the opposite over the hypotenuse. I find the ratio. Okay, if I have the ratio and I want to find the angle, I take the inverse, which is indicated with a little -1 after the sine. I find the inverse of the ratio. And I will then find the angle. Okay, so it's an undoing function. Okay, let's do one, I'm at the bottom, that's good. Okay, let's take a look at an example. Okay, I will draw a right triangle. And I will say, okay, what is the sine? And I will say this angle is equal to pi over 6. What is the sine of pi over 6? Okay, so what is the opposite over hypotenuse that has the angle of pi over 6? I'll take this, and I will go into over here in quadrant 1. Here's pi over 6. Of course, the sine is the y value, and so the sine of pi over 6 is 1/2. So the sine of pi over 6 is 1/2. Okay, so now, if I'm given, well, I can use that. It's not the prettiest triangle, but that's okay. If I'm given the ratio of 1/2, okay, what is the angle? Okay, what angle gives me gives me a ratio of 1/2? So this says, hey, the sine of the inverse sine of 1/2. How do I go backwards? How do I get the angle? I take the inverse sine of the ratio. And we know that we go back into here and we say, okay, I'm looking for a sine of 1/2. Get my paper down. And it is right here at pi over 6. Now I want to show you something. I also see the same answer coming out at 5 pi over 6. There's your 1/2 coming out as the sine of 5 pi over 6. And this is why we're going to restrict the range, so we're only going to be focusing on a single answer as opposed to 2 possible answers. So this is going to be, of course, this is pi over 6. Okay? So, speaking of that range, let's talk about that here briefly. Okay, because we just saw that you can have 2 possible answers in that example. Okay, like the square root function, we're going to restrict the ranges. We're going to restrict the outputs. We're going to restrict the angles. Okay, we just saw that 2 angles, pi over 6 and 5 pi over 6, have the same sine of 1/2. Well, we want to focus on one answer, so we're going to restrict our angles for inverse sine, inverse cosine, and inverse tangent. Restrict our outputs as follows. Our inverse sine is going to be between negative pi over 2 and pi over 2. Our inverse cosine is going to be between 0 and pi. And our inverse tangent is going to be between negative pi over 2 and pi over 2, the same as the inverse sine. Okay, that way we don't have a possibility of 2 answers. We're only going to have 1 answer in this case. Okay, let's take a look at some examples that will assist us with this. Evaluate exactly, example 1, if possible, the expression the inverse sine of negative root 3 over 2. Okay, what is this saying? In other words, and I'm going to write this down because it takes a little bit to get used to this. So in other words, what angle? Remember, the inverse gives us an angle. What angle? And we're talking between, well, this is the inverse sine, so we're going to be between negative pi over 2 and pi over 2. Negative pi over 2 and pi over 2 has a sine of negative root 3 over 2. So that's how we're reading this. Okay? Evaluate this. The inverse sine of negative root 3 over 2 is that what that's saying is find the angle and restrict that angle to be between negative pi over 2 and pi over 2, so I don't get more than 1, that has the sine of negative root 3 over 2. So we'll use the inverse sine. Okay, so the inverse sine, what angle has this? Well, we'll go on to our unit circle chart. Okay, now remember, sine the inverse sine is defined from negative pi over 2, which is back to here, up to pi over 2. So we're going to be in quadrant number 4 to 1 to find this. And which angle has the y value of negative 3 pi over, negative 3 pi over 2. Well, it looks like it's right here. Hang on a minute, I'm checking my work. Yes, okay. Checking my work. It is right here. If I go around the unit circle this way, it's 5 pi over 3, but I'm restricting myself to be between negative pi over 2 and pi over 2, so I'll go back. Negative pi over 6, negative pi over 4, negative pi over 3. Okay, so between negative pi over 2 and pi over 2, the sign that gives me a negative 3 pi over 2 is negative pi over 3. Okay, negative pi over 3 is how that works. Let's check it. And we'll use Desmos to check this. Okay, does the inverse sine of negative root 3 over 2 equal negative pi over 3? That, of course, is a question. Let's find out. Okay, pull out Desmos. Looks like I got to turn mine on. There we go. Get it in the window for you. Let's click into Desmos. And we're going to use our trig function. So we're going to go into our functions. And we're going to choose the trig option, and we want to know the inverse sine. So there's the inverse sine function. And we want to find the inverse sine of negative root 3 over 2. Negative, I'll make a fraction bar. Square root's down here on the left. Square root of 3 over 2. And that answer is negative 1.04, etc. Is that the same as negative pi over 3? So negative, again, I'll make a fraction. The pi key down next to the square root over 3. Let me tap there correctly. And sure enough, I got the same thing. Obviously, Desmos did not give me the exact answer of negative pi over 3, so I had to check that approximation, and we have the same approximation here. So we know that we're correct. Okay. So now you know how to check these. I won't worry about checking them again. Evaluate exactly, if possible, the expression, the inverse tangent of root 3. Okay, again, let's write down what that means. The inverse function gives us an angle. So, what angle? Okay, and we realize that we're going to restrict it because we don't want to get more than one answer, and our restriction for the inverse tangent function is the same as for the inverse sine function, from negative pi over 2 to pi over 2. Okay, so what angle between negative pi over 2 and pi over 2 has a tangent of the square root of 3. So that's the question. The inverse tangent of root 3 is saying what angle, when we find this, we will find the angle that has a tangent of root 3. Okay, so let's take a look at this using our chart. Okay, so here's the question. Let's look at our unit circle. Okay, again, so tangent is defined, the inverse tangent is defined again from negative root 2 over 2 to root 2 over 2. And you'll recall, I think I did this earlier, I put the tangents on the outside of mine, I wrote them in, and I would like to have the tangent be positive root 3. Well, here it is. It's in quadrant number 1. Okay, and if I look at that, that's taking place at pi over 3. Okay, at pi over 3, I get a tangent of the square root of 3. So this tells me that the answer is the square root of 3. I should have noted up here that I was correct, by the way. And you can check that with your calculator with Desmos. All right, last question for this video. Evaluate exactly, if possible, the expression, the inverse cosine of 1/4. Well, 1/4 is not one of our known angles. It's not on our unit circle. So we don't have an exact value for this one. Okay, so we're going to use our calculator for this, but let's first write down what this means. Okay, the inverse cosine of 1/4 is saying, what is the angle that gives me a cosine of 1/4? So what angle? And again, cosine is, the inverse cosine is restricted. We want to look between 0 and pi, so we don't have more than one answer. Okay, and we're going to say what angle between 0 and pi has a cosine of 1/4. And so this is simply a calculator problem. There's no exact answer to this one. What is the inverse cosine of 1/4? Well, let's go back. Let's go into our Desmos. And okay, I'll go into here and I'm going to go and say, okay, I'll use row 3 here. I'll go to my functions. I want the inverse cosine function. And I want to put in 1/4. Whoops, I put in 4 first. That was a mistake. Let's go back and put in a 1/4. And it looks like the radians, okay, remember we're in radian mode here. If you want to double check, we can, we're in here, we're in radian mode using pi. The angle would be 1.32 approximately radians, 1.32 radians. Okay, so we don't have an exact answer for this one, but we can say that it is, I'm going to write this as approximately equal to 1.32, and I want to note that that is radians, not degrees. If you want to change that to degrees, then I change it with the pi radians is 180 degrees, and you can change that to degrees. So there you have it, the inverse functions and what they mean.